So yesterday we did a couple of things. So we have sent data from our Node MCU to the cloud, to the MQTT, and then from there we have taken it from the MQTT and then pushed it to our regular work, Node-RED, and then we have shown the values on there, right? And then we have got some values from the Node-RED to the MQTT and from MQTT to the our chip. So we have done some work considered. So today what we are going to do is I'm going to build a device, small IoT device, wherein I'm going to pick up the room temperature and humidity, and I'll take both of them, and then I'll try to push them to the MQTT, into the MQTT server, and on MQTT, from MQTT I'm going to take it into the node RED, and from node RED I'm going to connect to one of the free cloud called our what to say like IBM Watson, right? So I'm going to push this data back into the IBM Watson cloud. We are going to do that process today. Right? So this is all from yesterday's work, right? So if you are trying to take any backup of this particular thing, right? So normally what you can do is you just have to go into this export and export to clipboard, right? You will have all the data as part of the copy. Current load. Then copy all of that and export to clipboard. It is available there. All you need to do is you just have to go to any you just have to copy them. Tomorrow, if there is something wrong with the device and it has lost all the data, all you need to do is just need to install that particular Node-RED, and then you can import the same way how we have exported. Right? So you can go to the same place, export, import, and then clipboard, and then you can pick the data. You can copy that there, and then you can do the job. So for our experimental purpose, I'll delete all of this. Right, so same, I have done some configurations here. So this is a sensor which will pick up the temperature and humidity of this room. Then we pick the data and push this to the Node-RED. This Node-RED. And from here, I'm gonna push the data back into the application. Right? So we're going to have a sensor. Right? Sensor is DHT. Sensor name is DHT11, and then we are going to pick the data from here, and we have something called Node MCU, which is a microcontroller, right? Which is a microcontroller, and we are going to have Raspberry Pi, which is a microprocessor, right? So in microprocessor, we are going to have MQTT server, that's a broker, and Node-RED application, right? So our goal is to send temperature and humidity to a cloud. So in our case, we're going to push the data to IBM Bluemix. Right? So Bluemix, we're going to do this job. All right. So here, what we are trying to do is we are trying to build two different devices. Right. So this is device one, and this is device two. Okay. And third thing is, so this is a cloud one. Device one and device two and cloud. All right, so in a normal sense, so I would like to show you one particular presentation slide. So let me go back. Okay. So as you see it here, so we are going to have these two together are called device. All right. So and we are going to have one more device called gateway that you can see as a communications, and then that will help you to push the data back into the cloud. All right. So in another sense, let me search if that is available. Node MCU Raspberry Pi and IBM. So if you search for this, let's see if I find any. No. Okay, let's say you are trying to connect Raspberry Pi and BC547 and relay. This is connected to our Node MCU, and Raspberry Pi is connected to the cloud, right? So which is trying to control the data. All right. So we're going to do the same job here. Let's go down and start building device. So in this case, we are trying to choose uh, board a microcontroller which is called as Node MCU. We need to select that first. So this is an Arduino IDE wherein you're going to write some C++ programming in this case. But for you guys, as you are AI guys, you would be writing a Python code on the Raspberry Pi. All right, Raspberry Pi will pick that data. Even Raspberry Pi has some things, but to show something different, right? So IoT device, how they will be in real world. So these are it is. Right? They are going to connect to the Raspberry Pi. They're going to share the information. All right. So in Raspberry Pi, what you're going to do is you're going to write a Python code that will pick all the data which is coming from different devices. That you're going to do it as part of your AI integration application. All right. So in this case, so let me take one example. All right, first thing is let me test whether this particular DHT sensor is working. So first I'll do that. So examples, and then I have imported that already, DHT sensor library. I need to go to the tester. Let me pick it up. All right. So I have taken this one. All right. So this is a tester application. Here in this case, I have connected to pin number 5. All right. So here you can see a pin number 5, blue wire which is coming to pin number 5. This you can get it from uh, the top one. Right. So wherein you can see GPIO 05, right? The second one from the top on the right side. Right. So top one on the right side you see number of pins. There is one pin called D1, and the other side you see something called GPIO 05. Right. So the number 5 is nothing but this one. Right. So you're going to see that. And then the sensor type is DST11. Right. So we have different sensors wherein the accuracy is little more in the other cases. This is bit okay for the domestic applications like this, right? For the experimental applications like this, right? So DST11, and then I'm going to get all the data. Let me go ahead and compile this one. Before compiling, what I have to do is I need to choose the board. Otherwise, the compilation will not happen. So here in this case, I need to come here and choose the board, Node MCU 12. I'm going to select that. Then I'm going to come back again, and I need to select the port number because this is an USB port and it has to reach the port here. Right. And then you're going to come here.
So Python, which ID you prefer to work with this?
Sorry.
Python, which ID you prefer?
In Raspberry Pi, we have an inbuilt Python ID, which is available. So where you can write code there, or you can write in your laptop and you push the code. That's it. The same way how it is operating on your laptop, it will be the same way how it operates there.
Which ID?
It's Python. Yeah. Tony ID is available, and Python default Python ID is also available.
Can you mention one microcontroller plus one device? So that
You can go ahead with buy this one. So ESP NodeMCU 12. NodeMCU 12 is available. So, yes, with the temperature DHT11 is the temperature sensor. You can get that. Even you can order it on Amazon also. It's okay. So guys, I have selected this one. I'm trying to compile it now. I'm trying to compile it. Let me go ahead and do that. And yesterday we have seen one example called PubSub client, wherein from chip we are able to send the data, send a hello message, and from there we have received a message. Right? So we have done the job. Now today my job is to pick one sensor and that data, and then push the same data back into the cloud. Okay. So here I'm done with this, and let me upload the code. What's happening here is it is trying to prepare a flash file, right? So in the other sense, we call it as a firmware, right? It is trying to build the firmware, whatever code we have, and that firmware will be transmitted into this particular microcontroller. And from then onwards, the microcontroller will work according to whatever instructions are there. According to that, it will be working. So, and the microcontroller job is to do the work repeatedly. Microprocessors, we can do parallelly 10 to 15 different items at a time. But in case of microcontrollers, it does a repeated task, right? So in our case, let me go ahead and put this URL. Okay, we are getting the data. So room is pretty hot, I guess. It's showing 27 here. All right, let me blow air and check if sensor is working. Yes, it is. All right. So you can see the humidity part, which is raising up. All right, so it's gone down to 85 and 95 again. So 95 is the maximum. So that's what I can see. Right. The temperature also, according to your situation, it is trying to raise it. Right? All right. So here, the first test is successful. We are able to successfully test the sensor. So this is done. This is done. Now we need to have something called PubSub client. PubSub client, so that we can push the data into MQTT. Right. So let me go ahead and pick an example. So we have something called examples. All right, so this sample codes I'll try to provide you guys so that you just have to dump them in your NodeMCU if you are planning for a NodeMCU. Or otherwise, you can go ahead just with the Raspberry Pi also, it is good. PubSub. So we need to go with this. Let me open that. And I'm trying to integrate this particular temperature sensor code into that code. Right? So we're going to do that. All right, so this particular thing will help me to pick the data. So just quality dot 605b. So it is 192, 168, 1.3. So it is available. So, and when you try looking at this code, right? So I'll go with the DHT and then I'm trying to push it to the Raspberry Pi. So just so here in this case, what's happening here is there are a couple of things that's going on here. All right. Okay. So the execution starts from a method called setup method. All right. So and this setup method it will run only once. This setup method, whenever we have powered our microcontroller, it will run only once. That means whatever configurations you are trying to do, so whatever Wi-Fi settings, whichever you are trying to do, right? You need to do everything here in this case, right? So whether you are trying to reach the Wi-Fi and whether you are trying to reach the MQTT server, whether you are trying to reach the cloud, anything, whatever initial related stuff, you need to do it here, right? Here we are going to do a couple of things here. First thing is we are setting the Wi-Fi. It is calling a method called setup Wi-Fi method. So let me go down here and check where Wi-Fi is. So here is the Wi-Fi method. Right? So it starts here and ends at line number 62. And here in this case, what it is trying to do is, it is trying to search for, it is trying to call a method called Wi-Fi.begin, and it is passing the Wi-Fi username and password. And in this case, once it has run this particular method, it is going to check the status whether WL is connected or not. If it is connected, then it is taking you through the other process. If it is not connecting, then it is delaying for 500 milliseconds and then printing a dot saying that it is trying to do a connection path, something like that. So for the user, and then it will keep trying that particular Wi-Fi username and password. All right. So you should be very cautious because even if there is a space here like this will not work. You should be very, very careful in this case. Right?
You can capture the SSID.
Yes, you can show that SSID back into this, but thing is, the what to say, the it has to be the same format how it is being there in the regular. All right. So in setup method, yes, it is done, and then what it's gonna show is it's gonna show the once it is connected, it is gonna show the local IP address of my modems. Right? So once you connect your laptop to your router, it will have an IP assigned. The same way, even the node MCU will be assigned an IP address. That's exactly what we are trying to show. And then what we are trying to do is we are trying to set up the server. This is nothing but this is a call to the Raspberry Pi MQTT broker. We are trying to have a connection to the broker and we are trying to reach it. What if the server is down? This method will not be through. It keeps doing the same work again and again. Unless the MQTT server is available, this is not going to go through from this particular. Let's say everything is successful. We are able to successfully connect to the Wi-Fi and we are able to reach the server and we are able to connect our node MCU into the cloud, into the Raspberry Pi. Once you are able to done, it is going to come into the loop method. In this loop method, it is going to pick up some data and it is trying to publish the data back into the Raspberry Pi. Right? So in this case, there's a topic called out topic. What is the topic? The channel name. Right? So yesterday we were talking about YouTube and a channel name, wherein someone is going to publish the videos on that particular channel. We are going to view on that particular channel. So same thing. Topic is nothing but a channel in our case. Right? So in this channel, my node MCU is trying to push some data into the MQTT, not cloud. MQTT part, I mean cloud part comes later. Right? So we are trying to push the data into the MQTT. Right? So we are trying to do it.
I have a question.
Yes.
So now this is a microcontroller, right?
Yes.
And then the other sensor which captures the information. And then you have another thing which is the Raspberry Pi. And I'm unable to relate the relation. So now what you are trying is getting the temperature from the sensor and passing it to microcontroller. And where this Raspberry comes into this.
Why this Raspberry Pi is coming to this? That's a good question, actually. All right. So we have some concept called gateways in IoT. Gateway is nothing but if you are having, let's say, you are having 100 devices, 100 beds in a hospital. You have two options, right? Either you connect this particular device directly into the cloud and share the information, all right? Or you connect to a local host and share the information there, all right? All 100 hosts will be connected to that particular host, that gateway, and this gateway will collect all the information and it will have only one connection with the cloud. Which one is the best solution? Gateway is the best because the number of connections to the cloud is an expensive job. All right. So in case of IoT, so let's say in case of Uber, it is needed because all devices have to be connected to the cloud because the accuracy is important for them. But in our case, we are going to use hardly few kilobytes of data which will be transmitted between the cloud and the. So for that, if you are having an establishing a connection between the cloud and devices, let's say if you are having 100, that is fine. If you are having 1,000, that is again a bit difficult. Here, when you think about at the architect level, you should think this. When you're trying to do job, right? So you need to segregate that and then drill down and then distribute these particular jobs, right? So what I'm trying to show you is one device. I can connect 100 devices to Raspberry Pi. Raspberry Pi is a consolidated point, and then it will pick up that data, and it will consolidate whatever values you want, right? So, and then it will give you the data, right? So let's say this node MCU is in one field. Like this, 100 fields are there. Right? All those 100 fields will be collecting that data and pushing back to the Raspberry. On Raspberry Pi, you can have a consolidated report saying that from this particular client, this is the data. From this particular client, this is the data. Wherein you would be working on that data and then doing the work. So now I'm trying to show you a single device. Later, you can expand that to number of devices.
A follow-up question. This microcontroller to Raspberry, if you want to have a connection, should be on the same network or same.
Yes, it should be on the same.
So suppose take a hospital. So you have some rooms and you want to monitor the temperature. And then you have your central Raspberry. So say if it's not on the same network, then
okay.
If it's on the same, I know everything can be controlled at the my Raspberry board.
Okay.
You take the data, but if it's not, you're saying some fields, right, where you don't have, it's not in the same scope.
Yes,
it's on a different.
Then you're going with the public IP. Right, Raspberry Pi will be on the public IP address. Right, so as of now, let's say if it is in this room 192.168.1.3, if you go home and try to connect, it won't because you are outside the quality.net. Right? So then you would be exposing your Raspberry Pi to the outside world on a public IP.
And these devices are connected to that.
Yes.
And from there it goes
from
to
there. Perfect. Right? So hope you are understanding. Right.
So what
here in
is
this
the maximum length of this Wi-Fi on the
maximum distance.
distance?
Is it? So based on the Wi-Fi router range, right? So I have a router at home, wherein when I'm entering my street, it will be connected to my router. So Netgear router.
We are connecting this Wi-Fi to that Wi-Fi.
To that Raspberry. Into that Raspberry. Yes.
So what is the distance for this one?
So for example, in between these two, there's a router in between. Okay, router is acting as a medium. So wherever my router is reachable, I'm reachable for both the devices.
Even if you have the cable, right, stuff Wi-Fi, it can be across the entire building as well.
Yes, you can do that. Yes, you can. If you are having a LAN network, right? If you are having if you are on the same switch, this is more of a networking concept. If it is reachable, it is reachable. If it is not reachable, you want to make it public. But when you are going public, then you need to take a lot of care. All right. So, like for example, hackers will be there. How they'll get into your system very easily. So, how to secure yourself from them. So, all these challenges will be there. That you need to handle it properly. Otherwise, your Raspberry Pi will be down. You'll be so in one of the European country, right? So they hacked into all the home IoT devices, and from there they have done a DDoS attack on a bank on an European-based scam, and they have shut down the bank completely. Right? So these DDoS attacks will be more on IoT devices also. How to mitigate them, how to secure them. So nowadays we have a lot of solutions. A lot of people are working on it. So a lot of solutions are there. You can secure them easily. So if you buy a Chinese product and if you buy an iPhone, both are looks similar, right? If you go to Koti, you'll get an iPhone with a inverted Apple symbol, right? So for 5,000 hours, this is possible, right? Features also look similar, but when you talk about security, that's where the actual figure comes to the picture. So it does depends. Right? It does depends. All right. So here we are trying to push the value back into the cloud. Right? So and then here we have the loop concept, and we are trying to. In this case, I'm trying to share some value called the link value, but my concentration would be on sending the temperature data. Right? So let me go ahead and to save time, right? Let me check if the example is already done, because I have another 20 minutes now.
It's an inbuilt examples.
Yeah, these are inbuilt examples, but what now I'm trying to look is I have already done this example. So let me just pick it up and then quickly show it to you. I'll take a minute or two. Please excuse me for that. Yes, it is not available. What I'll do is I'll quickly get the changes, include them. So this is the first code that we need to include there. And then dst.begin is the first one, and then we need to include that in the same method. It is inside the setup method, right? We need to include that in the same way. And then we can go ahead and grab the values and check the values. Right. So in this loop method, I'm going to do the same job. Okay, and yeah, in my case, not worried about this, not this, this. All I'm worried about is data. Right. So I'm having humidity and temperature. So I'm going to take two different topics. So I'm going to share the values. What I'll do is try to pick up this one. So first, let me do a temperature, humidity value. Later, I'll do the temperature value. So in this case, temperature. I'm going to pass a value called HIC. That will be coming as part of my code. Alright, I'm going to push the value. Okay, I'm good here. Compile this. If there are any issues, it will be throwing me error here. So if there are no issues, you'll be able to successfully move the values up into the cloud. And then meanwhile, what I'll do is I'll quickly go into the Node MCU. And yesterday we were able to pick the data from MQTT, right? So here our MQTT channel, what is that? What is that? Temp. Temp is the topic, right? TEMP. Here. So humidity is our topic. I'm going to pick that up. And there's a local host. So server is also local host. So, and then there's an debug statement that is like an output for us to look into the data now. And I'll try to open the debug message console also. Okay, so this part is connected. Let me go back. Yes, compilation is done without any problem. Let me upload that. So upload is going on now. So meanwhile, what I'll do is I'll try to connect these two. Sure. And there's something called cloud, right? So we once the data reaches Raspberry Pi, from here we need to push it to the cloud. Right? So there's something called IoT Watson IoT device. Right? I'm gonna pick it up and I'm gonna connect these two into the cloud. Right? So in this case, I'm trying to do send some value into the, so it says connecting, is connected. Okay, let me check what is the data.
Sir, for now you are sending only humidity, not temperature.
Yes, only humidity, just one data point.
We can't send to.
We can send. So for the, so here in this case, it says 0. So I think data is not coming up. I'm just trying to change some data.
You need to connect the DTH level.
Which one?
DTH level 22.
It's already done. Okay. Type is also. So beginning is done. Beginning is done, and then we are trying to read. So nothing much. Nothing will stop us. Yes, we are getting the values. But some arbitrary data is coming in between, so you can ignore that. All right. So if I go here, so I'm getting the values here. You can see it, right? 29. Right? So and then some arbitrary values. Right? So that is all fine. So what I'm gonna do is I'm gonna open the cloud and check whether I'm receiving the data on the cloud side.
Even I can try from that.
Yes.
LGD.
Yes.
I tried it. Same topic.
Same topic. You able to see? I'm able to see here. Some data is coming in. This is a cloud part.
So how do you configure that for the you need to here there is no need to
Oh, we don't have this. This is a what to say like this is a free quick view link which is given by IBM, wherein you can quickly push the data into the cloud and then you can have a graphical representation of that.
you need to have the account on that.
No. I'm just you're seeing what I'm doing here, right? So I'm just opening my node, and then here is something called pop-up, quick start ID. I'm just hitting that. It is opening into the cloud. That means data is already been pushed into the cloud and to that ID. Right? On that ID, it is data is available. Okay. Temperature, it will not go beyond 40 and we will not survive beyond that temperature. So it says somewhere around 21,000 lakhs, okay, which is not possible. Right? So you don't have to worry. And let me do one more thing. So to quickly fix that issue, right? If I'm gonna do a quick check and then humidity part is less than 95. Then only I'm going to publish the data. I can fix that issue here. So to avoid such drastic changes in the backend, right? Which IP? So local IP. See, on Raspberry Pi we have both the service, Node RED application and MQTT. So when you look at the configuration, right, I just given you something called localhost. Localhost is nothing but it gives me that particular internal Raspberry MQTT. Yes.
So you need to have decided.
In this, I'm going to have the Raspberry Pi. So here I'm generating the data. I have some destination that is Raspberry Pi. I need to give the IP address of the Raspberry Pi. Yes, I have done it. I have done giving it. And then what I'm trying to do here is, when I'm done here, I'm trying to push the data back into the Raspberry Pi. Raspberry Pi MQTT is receiving it, and MQTT from MQTT it is going into the Node-RED application. From Node-RED, I'm picking this and then pushing into the cloud. Okay, so you're seeing this. Now you're getting a lot of things here, so that is fine because I was trying some GPS connectivity directly from a sensor, which is not possible. So it's okay. You can ignore this. Right. Then you can clear all of that data. So
Can you show that?
yes, here one, right? Yeah. So this is a local. So when you go into the local host, that is a local host. The locals.
So if I need to send to AWS, then I have to.
Yes, you need to connect. Yes. You can change the server IP to the endpoint of that particular thing, and then you need to enable this TLS, and then you need to configure this. You have a lot of changes. You know the rest of the changes, right? All right. Here in this case, let me restart this. It's connected. So here you can see clearly. So it is first trying to connect to the quality thought, and then it got an IP address, and then it is trying for an MQTT connection attention, and then once you are done that, you are trying to push the humidity value back into the cloud. Right? So let me show you some fun part. Right? Even in Raspberry Pi, we have something called Play Audio. Okay, I'm gonna connect this. It's Samantha is the one who will speak for us. So I'm not sure if it works here. Let me check. Maybe I have to connect the speaker to that. So there's a speaker which we can connect there, and then that will help us to voice out. It will voice out actually. Okay. So in France,
28.
Okay. Yeah, you can see that.
28.
Okay, I removed it. Good. I removed it. Otherwise, it will keep shouting at me like that. The value, whatever it is coming, right? It is voicing out.
Actually, it has to come from that side.
The speaker, like we are using the browser, right? Browser will be connected to our. See, you open YouTube on browser, and you're getting the voice out. So same way you are trying to get the voice.
That output you are sending on your laptop speaker.
Yes. Okay, so that's a fun part, and we can do a lot of things like this. All right. So here, if you observe, we can send an email also, email or Twitter. Right? Whenever someone is trying to come into my room, I can get a Twitter update saying that someone has logged in. Or let's say if some student is having an ID card and I want to know the attendance on Twitter, whenever he does that pattern. So I can push to anything, like any social networking applications also, like WhatsApp, right? So Facebook, and I can push it to the Instagram, right? So I can push it to the Telegram applications which are ready, right? You can try to do that. We can build a chatbot also, wherein you ask that and then it does the work. You can, simply you can do that. So without having much knowledge, right? So you can try to simply do this.
Can you show the manipulation of data?
Manipulation of data, okay. That you need to write a function actually. JavaScript function you need to write. So for example, let's say you have a function, right? Getting this data. And so for example, let's say you're getting the data. Right? So like normally, so let me go with the template. Normally you get the data as this message.payload. So, this is also a similar one, but we have a predefined template over there. So in this case, when you try to push, right, so you see this, you're getting a template data, right? So what I'll do is, I'll convert this into a quick JSON file, right? So that is like, I'll go with, uh, like let's say this is humidity, right? Humidity, and colon, whatever value I'm getting there, right? So I'm trying to put it there, and then close it. So let's say for case, I'll add one more thing called device ID. Device ID. So colon, and then let's say 1, 2, 3, 4, 5, 6. Count. So what I'm trying to do here is I'm trying to manipulate the value which is coming in to a different JSON format. JSON format is normally accepted by all the clouds. Right? So here I'm getting a raw data, and then just trying to convert that data into JSON, and then trying to push that back into the switches. Okay. Now you can see complete data which is coming.
This activity you are doing on your laptop and not on the
Raspberry Pi itself. This is on Raspberry Pi. It's not on mine. It is just an interface, web browser interface, wherein you are doing all this. Okay. I'm just trying to show all the easy ways for you so that you don't have to spend much time on IoT. You can concentrate on your core thing, that is the AI part. So here I'm trying to show all the easy ways and also all the tough ways. So next we'll switch into the tough ways. That is like Python, and then we're trying to connect to that and then trying to do the job. Okay. Clear? Any questions, guys? I have another 5 minutes. So here in this case, what you're trying to do is you're having a Node-RED server on your local machine. You're connecting the Raspberry Pi. You're getting the data onto your Node-RED server. That's a good nice try.
Then I have one more thought. I can get the temperature of my laptop and then publish it to Raspberry.
Yes, that's possible.
That means that acting my laptop as a kind of IoT device. And then based on the action, we can control the AC also.
Yes.
It's also possible.
Yes, it's possible. So you have this Python code which is available. This your Windows, right? So then in this case of Windows, then you need to check what is the internal command that can give you the temperature.
Yeah, that I'll get it.
You get this later. Alright, just try this one. So try this Watson thing and try to connect the humidity part and the temperature. Okay. So here you can see the actual code how you are trying to get. And so you can convert from one form to other form and then try to push the data. Okay. Any other doubts, guys? Any doubts here? Right. So today we are able to send the data from one place to the cloud. Tomorrow what we do is we'll take the command from the cloud and we'll do some action on the device. Reverse way. It's a reverse way how we are trying to do it. All right. Publish the data and